how many theoretical physicists does it take to change a light bulb? And you can ask any theoretical physicist and they will tell you that it only takes one person to call the janitor. My name's Martin Smith, and I've been on a quest for finding gravity, and this is the process of that quest. One of the things necessary for what I'm looking for has to do with luminiferous ether. It has been name changed many times, and I'll be going over that now. Okay, luminiferous ether has had its name changed many times. Permittivity and permeability renamed it free space. Einstein renamed it space-time. I'm going to call it null space, properties of null space. First properties I'm going to add to it is permittivity and permeability. Permeability deals with mu naught, and it has a mathematical point of 4 pi times 10 to the minus 7th Newton over amperes square, and that is in current, noted as capital I. Permeability has to do with induction and transformers, and it says basically a statement saying that magnetic fields have resistance in space. So if you were to take basically the properties of null space, if you were to take a 1 cube meter box, that's 1 meter by 1 meter by 1 meter high, put it out in space, take everything out of it, take out light, take out gravitons, take out every single particle out of that box, space would still have properties. And permeability of free space, again, has to do with resistance of magnetic fields through free space. Permittivity of free space has to do with resistance of electrons or charged particles through free space. Epsilon naught equals 8.8542 times 10 to the minus 12th, and it's measured in coulombs divided by Newton meters squared. So that's property 1, property 2, property 3. Going with the speed of light. So if you were to put a photon moving through that box as in 299,792,458 meters per second. A lot of people round this off to 3 million meters per second. The problem with doing that, as soon as you square it, you are actually 1.2% above the number in which you squared, above the square of this number, and that changes a lot of aspects of what you're dealing with. The fourth property of null space that I'm going to add to is the left-hand curl rule, not right hand. I'm going to go with the left hand. If you'll notice, the first 3 videos that I did were wrong. I used right-hand rule and went with the direction of the electron. Right-hand rule goes with the direction of the current. And the problem with current is that absolutely nothing moves in the direction of current. Electrons move in the opposite direction of current. The left-hand rule, what it does, you take your left hand, curl it, move it, point the thumb in the direction of the electron, and the curl tells you the direction of your field. Put the thumb in the direction of the electron, that is the direction of permittivity, and the curl is your permeability or magnetic induction or transforming or however direction it goes. Other way to think about it is if you have one electron moving this way, one electron moving this way. On the inside of that electron, both those fields are going to curl up. This one's going to curl up this direction. This one's going to curl up to this direction. And because the fields are going in the same way, it's going to take those 2 wires and pull them together. So I'm going to go with the left-hand curl rule rather than the right-hand rule, and it looks more like this. On an electron, you have this side, you have this side coming up, that side going down, and the electron moving in that direction. Okay, the fifth one I put a question mark next to. Waves such as photons only affect other waves for a short time. That means as one wave passes by another wave, whether it's different directions, one peak adds to another peak, or if it's opposite, one trough subtracts from the peak and makes it smaller. If they're going vaguely the same direction, again, peak to peak, they add up, and this is where we get a lot of pseudo particles that are there for one split second and gone the next. If you were to go out onto a lake, you would find that masses are the only thing in which will add photons together. So anytime you see photons be turned into energy, mass is involved. Anytime you see photons being added together, where you see two photons come together and you end up with a bigger photon, again, a mass was involved in order to do that. If you go to a lake and you watch waves come up to, say, a log, the log is bouncing up and down. Sometimes the log is stationary and the wave just comes up to it and bounces back. Other times you have two waves coming at it from different directions, and the bounce is actually higher. The energy of both waves comes together, creates a higher bounce on the log. When the log comes back down, it creates a wave on the other side that's actually the additive properties of those two waves together. Other times you'll see the log in which it just rides the wave, it goes up with the wave, it comes back down, and it doesn't affect. So the wave has an effect versus how much energy the wave has and how much mass the log has. So I put a question mark next to 5 under properties because it's the way I am seeing things. I'm saying that waves only get changed, only change direction, only get changed in anything else when they hit a mass. Okay, properties of null space, gravity well. I have a question mark near this one too. This is Einstein's theory of the gravity well. It is a theory, it is not proven. When Einstein came up with this theory, there were 4 possibilities. One was gravity, one was magnetic strength, one was electron ion density, and one of them was theoretical gravity wells, which Einstein came up himself. Each one of these 4 work under 1 over r square rule. And what Einstein did to make it really hard to disprove this theory, and he worked at a patent office, and one of the aspects of whether whether an object gets patented or not, or an idea gets patented, has to deal with what kind of argument is involved. And Einstein became an expert at making arguments. And his argument was to call it a gravity lensing, and then he changed that up into gravity wells. So the gravity well has to do with its property luminiferous ether. These other 3 are not, or I shouldn't say that. If gravity follows graviton being a really low energy photon, say under a frequency of a second or a wavelength of 4 or 5 miles, then that's a very low energy photon. If you have an extremely high density of it, then it would be gravity, but it would not be theoretical gravity wells. We see the effect of this well, but we have no actually proof of it being there because it is luminiferous ether, or renamed from luminiferous ether. Okay, and if it does not fall under theoretical gravity wells, then it is very likely to fall under what I'm looking at, it being as photon vortex waves that that again being the low energy photons. It's not so popular. It was a not very popular theory in the 1980s. And then on top of that, I placed two vortex waves on top of a spin with a double helix, and I just wrote down helix. And whether it goes clockwise or counterclockwise doesn't really matter, because the spin is so small that it actually red light actually travels past 6,000 electrons before it makes one complete rotation. And under that speed of rotation, the classical way of looking at a photon works just fine, whether you have one electric wave going this way, and if you come out of the page a magnetic wave, or you can switch them around, doesn't matter. They work pretty much the same. The photon vortex wave theory, let me rephrase that one. This is an old theory, it is not mine. So the photon helix theory with vortex waves added to it by me brings it more into a WAG, that's a wild ass guess. So it has a very low probability of being right. Gravitons in this model are photons that have been drained of energy until the frequency is smaller than very low frequency. Like I said, probably more like 1 hertz per second, or 1 cycle per second, or wavelengths of a couple thousand kilometers and bigger. Wavelengths, frequency smaller, wavelengths bigger. This model predicts photons breaking up with the rare event of collisions with matter. It predicts the recombining of photon parts at the same range or distance as a free body, being no longer trapped in the orbit. And it predicts photon vortex waves to be so abundant that they stack to make temporary particles. That means you take 1,000 photons moving in different directions to, say, that particular point on the paper. If you have thousands and thousands and thousands of photons all converging, and they hit that one spot all at the same second, they stack on top of each other and would make a huge wave. Another way to look at gravitation, as we have a helix, photon helix of very low energy striking an object. Most of these things would go past them, so it'd be probably a billion, trillion, or even greater odds than that of actually hitting. 1 in a trillion, 1 in a billion. Very small odds of it hitting, but when it does, part of it moves this item, gives energy to this item in this direction, and the other one goes off at an angle, and either hitting this or going great distances out to recombine, because eventually both these pieces here, if it hits this way, then it's going to get thrown off in other directions. If you look at string theory, what they're saying is the graviton hits an object and goes, as soon as it hits the object, it goes through, the graviton goes into another dimension, skips through all the particles in here, so it doesn't connect with, say, this particle here, doesn't connect at all with it, and then resurfaces, come back into our dimension over here. So what this does is we have gravitons hitting it from all sides. This one gets moved with very low energy this one way, this one gets moved with very low energy this way, because this one here just blocked a few gravitons from hitting it in this direction, so it actually moves. They actually move towards each other. And that is the properties of null space. Again, photon vortex waves, low probability. If I were to be gambling, I would go with Einstein's theory of gravity wells. That's because if you're putting $1 per dollar down on a bet, only an idiot would bet against Einstein. However, if the odds, just because the odds are greater than 50-50 that Einstein is right, does not mean that this theory is wrong and photon vortex theory is wrong, and that's why I'm pursuing it. And I will see you on the next video.